All right, welcome to Unit 2, Lesson 5, Part 2. Hopefully this won't take too long. We left off with example 2 here. Okay, so example 2 says, find, I like this wording, find the all. Instead of find all of the, it says find the all. It's fantastic. We're just going to cross that out and pretend it didn't happen. Okay, find all of the solutions of the polynomial function. Okay, keep in mind solutions. They mean zeros, x-intercepts, whatever. That means I can factor and t-bone this, but I have a situation where I cannot factor this, okay? And just like previous problems where we graphed and we couldn't find the x-intercepts, we kind of had to like factor them and divide and find them out. They give us this polynomial, p to the x equals negative 2x cubed plus 7x squared minus 4x minus 4, provided that x minus 2 is a factor. Now, this p of x is unfactorable right now, okay? This piece of information is very helpful and will help us find the other factors of that polynomial. We cannot factor that by grouping. That is not a quadratic, so we can't do slip and slide, or we cannot do product sum method, DOPS, whatever, okay? So what I'm going to do for a moment here is I am going to pull you away from this problem. If I have the number 100, and I say 2 is one of the factors, but I want 3 factors of 100, okay? And I say 2 is one of the factors. Okay, I can divide 100 by 2. I can divide out one of the factors, okay? And that would give me 50. And then let's say I know another factor. Well, that's 10 times 5, right? Because if I divide this by 10, I get 5. So my factors, I can get if I divide 2 times 10 times 5 gives me my 100, okay? So division helps us find factors, all right? So if I have one factor and I divide something by that one factor, I get the other factor. It's just like how we did reverse tabular. If I have, let's call it 6, and I know that 3 is a factor, okay? This is one of my factors. If I divide that out, I get the other factor because 3 times 2 is 6, okay? Keeping that in mind, let's go back up here and get rid of this. I have my polynomial p of x. I have a factor. I am going to use synthetic division. Okay, why am I going to use synthetic division? Because I'm looking at this and I see this is 1x plus or minus something. So synthetic division, just a quick review is, I got to solve this. Like I'm T-boning this, right? Boom. X would equal 2. My 2 goes in my backward L. And all I want from my big, bad polynomial is the coefficients with the signs. I don't want the x's anymore. All right? So I'm going to take negative 2, a positive 7, a negative 4, and another negative 4. I just took these values. Okay, I'm going to draw this line here. And this last term down here, this has to be 0. How do I know? Because this is a factor. When I divide something by a factor, I should get a remainder of 0. That's how I know it's a factor. All right? If I don't get a 0 here, something's wrong. Okay, let's do this. The process starts. I drop the first one, and I multiply. 2 times negative 2 gives me negative 4. I take that product of negative 4, and I always add it to the next. That's 3. 2 times 3 is 6. I add it. I get negative 2. 2 times negative 2 is, oh my God, that's a positive 2. 2 times positive 2 is 4. And I add that, and I should get 0. Okay? Goes in evenly. It works. Bam. Now, what we got to realize is what we have left here. What we have left here, this is x to the zeros. These are x to the ones. These are x squareds. So I technically have negative 2x squared plus 3x plus 2. All right? One of my factors they gave me is already x minus 2. I can factor this. It's a quadratic. I can factor that and get my other two factors. So that's exactly what I'm going to do. And the first thing I'm going to do is I don't like to have my lead term negative, so I'm going to take out a -1. That's going to flip the signs of everything on the inside. Okay, that becomes positive, -3x minus 2. All right? Now at this point, I'm going to use slip and slide. Okay? I take my 2 out front, I bring it to the back and multiply. So now I've got x squared minus 3x minus 4, because these two things multiply to -4. And my -1 just comes for the ride. This is definitely factorable. Two numbers that multiply to -4, that add to -3, it's x minus 4 and x plus 1. I still have my -1 coming for the ride. Now, do not forget, since I multiplied a 2 out, I can't stop here. I need to divide my 2 back into both ends. So when everything is all said and done, I have my -1. This turns into x minus 2. Since I cannot reduce 1/2 anymore, bottoms up, my 2 goes right out front. So that becomes 2x plus 1. Now, let's not forget, this was also a factor. Now, what do I have here? If I multiply all of this together, okay, I will end up with my original polynomial, okay? If I just multiply these two together, which is what I originally factored, I would end up with this, okay, the quadratic that I factored. But I still need to multiply that quadratic by the original factor to get my original polynomial, okay? Let me also make a comment. Isn't this a cubic? The degree is 3. So shouldn't I have 3 x's to solve for? 1, 2, and I need to bring down this one, 3. That is factored completely, but they don't want it factored completely. They want all the solutions. So when I factor, now I T-bone. X equals 2, okay? If I have 2x plus 1 equal to 0, I subtract 1, I get 2x equals -1, and then divide by 2. Okay, so there's my second answer. There's my first one. This next one is x equals a positive 2 as well. What do I do with this? There's no x to solve for. I don't got to worry about that at all. Okay, if I was factoring and they wanted it factored completely, I need that -1 there. But if I'm solving for answers, if I'm solving for x's, this has no x, so it doesn't matter. Okay? So how would I write my answers? Well, that's correct. If this was a short answer, that's fine. If this was multiple choice, they might say your x's equal, they might put it in curly braces, who knows. They would say -1/2 and 2. They would not write the number 2 twice. They might say, since 2 happens twice, that the solution 2 has a multiplicity of 2. This just means that this answer happens twice, okay? Remember, wasn't this cubic? Wasn't it a degree of 3? It was, so I should technically have 3 answers. I have 1/2, and then I have 2 that happens twice, all right? Not too bad. And this all starts with synthetic division. So I can divide out factors until I have something that is factorable, because we started out with something that was not factorable. Okay? All right. Example 3. Find all of the solutions to the polynomial, okay, p to the x equals x to the 4th plus 3x cubed minus 13x squared minus 51x minus 36, provided that x minus 3 is a root with a multiplicity of 2. Look at that. That is going to come in handy for us, okay? X minus 3 is a root with a multiplicity of 2. That means x equals -3 happens twice, all right? So I obviously cannot factor this x to the fourth, etc., etc. Okay, I cannot factor that. I need to factor it to find the solutions. So I'm going to use synthetic division until I end up with a polynomial that I can factor. All right, now, this is important, okay? X minus 3 happens twice. So there's two things I want to explain to you. Number one, I don't have to flip the sign. And you're saying, Visca, what? Let me explain. You see right here, they give me the factor. I found the root, okay? I found the solution, and that's what I divide by. See, it's x equals 2. That's what I divide by here. They did not give me the factor. They actually gave me the solution or the root. So that is what I'm going to divide by. This came from the factor x plus 3, okay? And I solved it and got x minus 3. So that's the first thing I'd like to point out to you. They throw you a little curveball there. I can't tell you the number of students I had that flipped this sign. Oh, yeah, because I just get used to flipping it. No, you got to understand what you're dividing by in synthetic division. You need the solution or the root, which is negative 3. But this happens twice. So not only do I have one x plus 3 when I factor it, I should have a second x plus 3 because it happens twice. So after I divide by my first negative 3 here, when I solve that, I should have a second negative 3. I am going to divide twice by negative 3. How come? Because there is a multiplicity of 2 for that particular answer, negative 3. All right. Let's start doing this. Bang. I want to pull, this is 1x to the fourth. This is positive 3x cubed, negative 13, negative 51, negative 36. Let's do this. This was a 1, so I'm going to pull a 1, a positive 3, a negative 13, a negative 51, and a negative 36. Draw my line. I know this is a factor, so I should have a remainder of 0 when I'm all said and done. All right? Don't do that every time you divide synthetic. I know it should be 0. That's my check because it's a factor. That's why I put that there. If it is not a factor, that remainder may not. Well, if it's not a factor, it definitely won't be 0. But if they don't tell you whether it's a factor or not, maybe it turns out 0 the remainder. Maybe it doesn't. Okay, synthetic. I'm going to go through this a little bit quicker. Okay, we're past the crawling stage. Drop the 1. Negative 3 times 1 is negative 3. I add these to get 0. I multiply negative 3 times 0, 0. I add these to get negative 13. Multiply negative 3 times negative 13 and get 39. If I add those, I get negative 12. And negative 3 times negative 12 is a positive 36. And when I add those, I indeed get 0. Now, what I have left here, and I'm going to erase this. What I write in blue, you don't have to write. This is technically x to the 0, x to the 1, x squared, x cubed. I have 1x cubed, no x squareds, minus 13x's, minus 12. This is still not factorable, okay? So I can't just factor that. In the beginning of this problem, I told you that negative 3 happens twice. So I can divide by 2 negative 3's, and that's what I'm going to do next. Okay, and this is why synthetic division is so easy. My coefficients are already set up for me, okay, in black here underneath this green line, meaning now you can start to write. I'm going to write now, and you can start to write. I'm going to divide by my second negative 3, okay, and I just drop the 1. I do the process again. Negative 3 times 1 is negative 3. If I add them, it's negative 3. I multiply negative 3 times negative 3, I get 9. I add them, that gives me a negative 4. Negative 3 times negative 4 is positive 12. And since I know these are both factors, this should also get a remainder of 0, and it does. Boom, we are on fire! Now let's take a look at what we have left. Okay, I'm writing in blue, but you can write this. I have 1x squared minus 3x's minus 4. This is very factorable. In fact, We just did this in slip and slide in the previous problem. Two numbers that multiply to negative 4, that add to negative 3, it's x minus 4 times x plus 1. They're not asking me for a factored form. They're asking me for all the solutions. This solution would be x equals 4. This solution would be x equals negative 1. 4 and negative 1 are not all my solutions. Don't forget, x equals negative 3 is a root or solution they gave us. In fact, it happens twice. So my answers are right here. Let's see if that makes sense. My problem had a degree of 4. Okay? It has a degree of 4, so I should have 4 answers. 1, 2, 3, 4. I have 4 answers. If this is multiple choice, your answers might be negative 3, negative 1, and 4. Yep. But negative 3 happens twice, so it would have a multiplicity of 2. Okay? Maybe in multiple choice, your answer is just like this. They actually list negative 3 as a multiplicity of 2. Okay? Maybe they don't have to list that. All the solutions you get, well, you get negative 3. Yeah, that happens here and here. You get negative 1, and you get 4. Maybe it's listed like this. Okay? But if they include multiplicities, that happens twice. So I need to state that as a multiplicity of 2. Those are my 4 answers. Here's answer number 1 of 4. Here's answer number 2 of 4. This is numbers 3 and 4 because it happens twice. It's my 3rd and 4th answer. Okay? It's a degree 4. I should have 4 answers. Guys are good. Good. All right, last one. Last one. Given the polynomial p to the x equals x to the 4th minus 5x cubed plus 3x squared minus 45x minus 54. They're asking us for a couple of things here. All right? And let's start, obviously, with the first one. Write the polynomial in factored form. Okay? So I need to write this in factored form. When it says factored form, they just want me to write it with my booty cheeks or parentheses all next to each other. Now look, this is the 4th power, right? So when I'm all said and done, I should have 4 possible solutions to solve from my factors. All right? But factored form just means put the parentheses. Don't solve them. Just put the parentheses. Now, I cannot factor that. But they tell me x minus 6 is a factor. Okay, that is 1x plus or minus something, synthetic division. So if this is a factor, that's going to be one of my booty cheeks in my answer. It has to be. That's a factor. If I solve that, I get x equals 6. That is what I am dividing by in synthetic division. And again, a positive 1, negative 5, positive 3, negative 45, and negative 54. All of those coefficients are going to go right here. 1 minus 5 plus 3 minus 45 minus 54. And since I know this is a factor, my last term is my remainder. It should be 0. You don't have to write that now. I'm just writing it now. And R stands for remainder. Don't look at this later and say, why is he writing the word or there? 0 is my remainder. Okay? Drop the 1. 6 times 1 is 6. If I add them, that gives me 1. 6 times 1 is 6. If I add them, I get 9. 6 times 9 is 54. And if I add these things together, all right, I get a positive 9. And 6 times 9, again, is 54. And if I add them, my 0 works out right. Now, if I did this right, okay, and you can continue to write what I'm writing down, I should have 1x cubed plus 1x squared plus 9x's plus 9. I don't have anything else to divide into here. I cannot make this I can't divide one more thing out and make it a quadratic. All right? So this has to be factorable. Anytime I have 4 terms, the only way I know how to factor this right now is by grouping. I group the first 2 together and the second 2. Let's do this. Okay, I can pull out an x squared. That would leave me x plus 1. So I'm hoping that when I divide out the second parenthesis here in green, I'm going to take out a 9, it would leave me an x plus 1. And it does. So when I rewrite this, these 2 go in their own parenthesis, x squared plus 9. Okay, and these 2 go in their own parenthesis as well, x plus 1. That is factored completely. X squared plus 9 does not factor. If this was x squared minus 9, I could say x plus 3, x minus 3. But it is not minus 9, that is plus 9, that is unfactorable. And let's not forget, this is also a factor. This right here is factored completely. Completely factored, because x squared plus 9 does not factor. Now, state all the solutions. I'm going to do this work. There's not a lot of space here. I'm going to do this right here. I'm going to T-bone all these. So I have x squared plus 9, x plus 1, and x minus 6. Well, the 2 on the right, the middle and the right are easy. X equals 6 is the solution, and x equals negative 1. Okay? How can I solve for x squared plus 9? Well, again, I set each one of these equal to 0 and solve, right? X squared plus 9 equals 0. Okay, so I've got one x. So I'm going to do opposite math here. Subtract 9 from both sides. I get x squared equals negative 9. Now I have to take the square root. The square root of x gives me x equals the square root of negative 9. I love when students tell me, we can't do that. We just learned imaginary numbers not too long ago. The negative pops out and becomes an I. So the square root of negative 9, this pops out and becomes I radical 9. The square root of 9 is 3, so that's 3i. That's 3i. However, isn't this a 2? It's a degree 2. Shouldn't I have 2 answers? Remember, whenever you have something squared and you take the square root of it, plus and minus. So really, this was a power 4 when I started. Power 4. I should have 4 answers. I have a negative 3i. That's 1. I have a positive 3i. That's 2. I have a negative 1. That's my third answer. And I have a 6. That's my fourth answer. So all my solutions, x equals plus and minus 3i, negative 1, and 6. All right? Let's state the end behavior. This is easy. Oh, my goodness. What is my first term? Let's go back. What is it for? It's positive x to the 4th, isn't it? Bang, bang. There it is, right there. Positive x to the 4th. So I come down here. If this is x to the 4th, I know it's an even degree. So it is going to go, it'll look like a parabola. And since my lead term is positive, I know it's a smiley face. Okay, it goes up. So if I want to write this the proper terminology, okay, as x goes to positive infinity or to the right, my y value will go up. Y would go to positive infinity up. As x goes to the left, or negative infinity, my y still goes up to positive infinity. All right? So that would be the end behavior, I guess. I mean, I guess. I know that's it. All right? Now, if they want me to sketch the function, they should really ask you for the y-intercept. Okay? They should, because that's one more thing that's going to help us make this a little bit more accurate as we sketch. Now, again, I'm going to look at my original function. To find the y-intercept, we set every x equal to 0. So there's actually a shortcut way to do this. If I make this a 0, it goes bye-bye. If I make this a 0, bye-bye. This a 0, bye-bye. This is 0, bye. I just end up with this. It's negative 54. So when they ask you for the y-intercept, it is your term without an x, your constant, so to speak, negative 54. All right? It is your term without the x. So it's at y equals negative 54. Now I'm going to take my solutions, my behavior, and my y-intercept, and I'm going to sketch this graph. All right? Let's do this. Da-da-da-da. Okay, just a little graph here. Just a little graph. I'm going to do a little graph. Now, at 6, I'll just put a tick mark here and call that 6. Negative 1, I mean, my solutions are the roots. They're the x-intercepts, right? Here, negative 1. Okay, so, but these, those are imaginary. They are not real. So guess what? That is where it does not really touch the x-intercept. Imaginary numbers do not cross the x-intercept. So or the x-axis, they are not x-intercepts. It would cross twice. When they are real numbers, you will have real x-intercepts. If they are imaginary and they are not real, then they are not real x-intercepts. They don't really cross the x-intercept. Okay? So, my y-intercept is negative 54. I just put a line down here and call it negative 54. It's a sketch. I know it's not to scale, but wherever it crosses, I'm telling you that's negative 54. And I know my arrows, they both go up forever. So I'm going to draw an up arrow this way on the right side, and up arrow this way on the left side. And I'm going to make sure it goes through all my points. Negative 1 and 6 on the x-axis, and 54 on the y-axis. So it might come down like this. Cross here, do one of these things, do one of these things, go up like that. I don't know, that's accurate. That's good. Do you got to have this little bump out part here? No. If you drew something that looked like this, down through here, kind of look like that, I mean, that's a sketch of what it might look like because it still goes up forever on the left and right. It still crosses at 6 and negative 1 on the x, and it still crosses at 54 on the y. You're good. You're good, you're good, you're good. It's good. It's good. And we're done. Now you got some homework to do. All right, I will see you for Unit 2, Lesson 6, maybe, hopefully. I miss you when I don't talk to you. So be there. All right, I'll see you. Bye.